What's up, math fans? Today we're gonna do solving systems of three equations. So three equations generally gonna have three variables, or a total of three. If you look here, I only have x and z, but up here I have x, y, and z, another x, y, and z here. So what this is it represents three equations represent three lines, just like two equations used to represent two lines. So if you took Algebra 1, and I have videos on solving systems of equations using elimination and a separate one on using substitution. So hopefully you're already good at that, and you're gonna use all your skills to solve something like this, which uses both substitution and elimination in the same problem. It's kind of like a puzzle. You want to pick it apart and do what you can to isolate one variable at a time. Sometimes you can't, so the best you can hope for is to cancel out one variable, and then you work your way down to two variables, and then from there you get to one variable, and you'll see what I mean in a minute. Okay, so if z is alone, if you have one letter alone, it's kind of a hint that you want to use substitution. If you have a variable isolated already, that's your hint that you want to use substitution. Usually if I see my variables lined up, then I want to use elimination. Here I have two variables lined up. The reason I'm going with z is because z is, I would call this in terms of x. Z is equal to something to do with x. Here, x is in terms of y and z. That's two variables. So it doesn't clean it up as nicely. This one looks like it's going to clean up nicer. So wherever I see a z, all right, I'll even highlight that for you in pink. Wherever I see a z here, I'm going to take the negative 3x minus 1 and plug it in. And I might even do that to both of them. So I see another z here, I'll plug it in there also. So I'm going to create two brand new equations based on substitution or replacing. All right? So let's see. I'm going to go here and I'm going to rewrite this. So I have negative x minus y minus 3 times z. Instead of z, I'm going to write negative 3x minus 1. That was my z, equals negative 9 still, equals negative 9 still. And then this one will be x equals 5y minus whatever z is, and z is negative 3x minus 1, close it, plus 23 is going to drop down also. All right? The reason I want to put those parentheses there is to make you aware that you're not just subtracting the first term, you're subtracting, again, I'll show you to in pink, you're subtracting both terms. So I'm going to distribute that negative to both terms there, and I'm going to here distribute the negative 3 to both terms there. So this will be negative x minus y plus 9x plus 3, because a negative times a negative 1 is positive 3, and then that equals negative 9. So generally you want to try to consolidate or combine like terms. So this is a negative x and a 9x, that's going to give me positive 8x, right, because I combined negative 1, positive 9, gives you positive 8, and then just drop everything else down. So minus y plus 3 equals negative 9. Kind of looks messy. I'm going to consolidate as much as I can. I see more like terms. Let me bring that 3 over to the other side. So 8x minus y equals negative 12. That's as clean as I can get it. If you want to play around with it, you maybe can add y to both sides and then add 12 to both sides. That way you get y alone. If you get y alone, maybe you can then go back, plug it in somewhere. So there's different ways to play with it, whatever you see, whatever jumps out at you. This is just my way. What I do is I look for what's obvious and I plug in and see where it gets me. So this might not even be right. I'm just seeing where it gets me. So here, x equals 5y plus 3x plus 1. Right? If you're distributing a negative, the signs inside change. And then plus 23 drops down. Again, we want to consolidate. So I have x equals, what is this? 5y and 3x are not like terms, but the 1 plus 23, I might as well combine those. So that's 5y plus 3x plus 24. But I noticed I have an x on both sides. So again, I want to bring everything, all my like terms together. So I'm going to bring that negative 3x. Now you have a couple of options actually. You could bring the negative 3x over here and leave x alone. Or, now I'm planning ahead, I'm seeing something. I see an x and a y here. So maybe I do want the x and the y on the same side, and maybe I want the number on the other side, kind of like how I have it here. I have an x, I have a y, and then I have a number on the other side of the equal sign. So actually, I'm going to stop myself, and I'm going to bring the x, I'm going to subtract x, bring it to this side, and I'm going to get that 24 over there. So I'll subtract 24. Subtract 24. So what happens is, this is gone, this is gone. So negative 24 is now on this side all alone, and then I got 5y, 3x minus x plus 2x. All right? So I cleaned it up a little. I got all my like terms together. The z is gone completely. So this was very helpful. This, when they tell you what the value of z is, it gets rid of the z in the other equations. So now I have 2 equations out of 3 equations, and they're 2 much easier equations. This is an Algebra 1 question now. Any Algebra 1 student should be able to line up their like terms. So I'm going to reverse this. I'm going to put the 2x plus 5y, that way I have my like terms. Notice when I said reverse, I'm using the commutative property, and then equals negative 24. So now I got to use elimination. I'm done with my substitution, now I'm going to use elimination, which means I need inverses, so I can multiply by 5 on top, or I can multiply by negative 4 on the bottom. It's up to you, whatever you want to cancel out. Because I have a 5 down here, that means I need a 5 as my coefficient here, so I'm going to go with that. I'm going to multiply by 5, and I'm going to distribute the 5 to all 3 terms only on the top, and you'll see what happens. So my new equation becomes 40x minus 5y equals, what is that, negative 60? And again, if I'm going too fast, just pause it, do the math yourself, and then come back and make sure you're with me. All right, don't just keep trying to catch up. No. Do it on your own. So this I'm going to drop down. 2x plus 5y equals negative 24. And what's nice is I have additive inverses here, so they will cancel out. A lot of people think that, oh, something's supposed to cancel out right away. Not necessarily. You have to find the least common multiple. You have to create inverses yourself. You have to do some extra math. And then when you add, if I have opposite signs, they'll cancel. If you don't have opposite signs, you don't add. You might have to subtract. The goal is to get something to cancel, so you do what you have to do as long as it's legal mathematically. Legal mathematically means you're doing the same thing to all terms. So if I'm multiplying by 5, I'm doing it to all terms. If I'm adding everything straight down. Some people like to add here, but then subtract there, and then subtract. You have to do the same thing to all terms. So here, I have 42x equals, what is this, negative 84. And lucky for me, that is divisible by 42, and x equals negative 2. So nice and clean. X equals negative 2. All right? I guess I'm done, but guess what? The question is going to say to solve. It probably will say solve for all three variables, x, y, and z. And remember, if this originally means 3 lines, you got a line going this way, you got a line going this way, and you might have a third line coming out at you like that. And so it's 3 dimensions here. It's not 2 dimensions like you're used to. So your point of intersection of all 3 lines would actually be not just x and y like you're used to, it's going to be x, y, z. So let's find them all. Now that I have x, I can go back. I'm going to go back to one of these 2. So I'm going one step above. Pick my favorite equation. I'll go with the second one. That's 2x plus 5y equals negative 24. That's 2 times negative 2 plus 5y equals negative 24. I replaced or substituted the x with a negative 2. And that's negative 4 plus 5y equals negative 24. Add 4 to both sides. 5y equals negative 20, divide by 5, and we now have y alone. Y is equal to negative 4. So I got negative 2, now I have negative 4. Now we go back to the beginning of the beginning, one of the original 3, first, second, or third. Now that I have x and y, I can find z. It should work for all 3. I'm going to chase the easiest one. Z equals negative 3x minus 1. So that means, if you can see this, z equals negative 3x minus 1. I got that from the beginning, which means z equals negative 3 times negative 2 minus 1. So z equals, let me do this in one step. Negative 3 times negative 2 is positive 6, minus 1 is 5. So there are your three answers, all right? So where do those three lines intersect? The three lines intersect at negative 2, comma, negative 4, comma, 5. All right? And again, thanks for watching. I really appreciate you when you like, share, and subscribe because that keeps me doing these type of videos. Remember, there's no Professor Noy without the math fans. Thanks for watching. See ya.